Picture this. For decades, really, the entire technology world has been absolutely obsessed with one agonizing question. Who is going to write all the code?
Right, because we never seem to have enough developers.
Exactly. Companies fought tooth and nail for talent. Boot camps popped up on every corner, and learning to code was touted as the ultimate bulletproof career move.
It was the gold rush.
It was, but suddenly the landscape has completely shifted. Today, we have artificial intelligence that can generate thousands of lines of functioning code in seconds.
Just instantly.
Yeah, the scarcity of code is entirely gone. But this absolute abundance creates a terrifying new question, and what's wild is that almost nobody in the tech world is actually asking it. Okay, let's unpack this.
It really is a massive blind spot for the industry. The underlying assumption has always been that producing code is the exact same thing as producing software.
Which seems logical at first glance.
Right. Therefore, if an AI can just spit out code instantly, our problems are solved. But generating code is actually the easy part. Living with the consequences of that code for the next 20 years, maintaining it, understanding it, that is an entirely different story.
And that brings us to the mission of today's deep dive. We are going to explore the hidden looming crisis of AI-generated software and the urgent need for a completely new digital philosophy.
We have some incredibly rich material for this.
We do. Our guides for this are a really thought-provoking article titled AI Will Write the Code, but Who Will Take Responsibility for the Life of Software by Valeri Rakitine. He's the founder of the Eco-Programming Alliance. And we're also looking at a strategic planning document that outlines an eco-programming manifesto.
It's a profound set of documents. The author is fundamentally challenging how we perceive the digital world, arguing that we are now capable of producing software much faster than human beings can actually comprehend the systems they're creating.
I want to speak directly to you, the listener, right now. Whether you are a tech leader prepping for a massive strategy, meeting a developer wondering about the future of your career, or honestly just someone who relies on digital apps every single day to run your life. Understanding the fragile foundation of our digital world is going to completely change how you view technology.
You will definitely never look at a simple app update the same way again.
Definitely not. So to really grasp the scale of the crisis, Rakitine is pointing out we have to look at what he calls the 3 levels of software creation.
Because right now the industry tends to lump all 3 of these together into one bucket called programming.
Right.
But they are distinct disciplines, and the rapid rise of AI is forcing us to acknowledge the boundaries between them.
I always assumed programming was just, typing the instructions. Let's break those 3 levels down because the distinction changes everything.
Sure. So level 1 is simply writing code. This is the mechanical act of translating a human idea into specific syntax and instructions that a machine can execute.
The typing part.
Exactly. And this is precisely the domain that AI is taking over right now. Large language models are incredibly proficient at this. They can scaffold applications, which basically means they can instantly generate all the boring structural boilerplate code so a human doesn't have to.
They can translate between different programming languages, too.
Yes, and autocomplete complex logic. Level 1 is rapidly becoming a solved problem.
It's essentially turning software development into a giant automated factory, mass production of digital parts.
That's a great way to put it, a factory. But then we move up to level 2, which is designing algorithms and systems.
Okay, how is that different?
This is about structuring the overarching logic, planning the architecture, and mapping out the long-term evolution of the software. AI can assist here, perhaps suggesting a pattern, but it remains a profoundly human intellectual challenge.
Because it requires a broader understanding.
Right. You have to understand how different components interact, how data flows safely, and how to preserve clarity as a system grows in size and complexity. It's less like laying bricks and more like urban planning.
Which makes perfect sense. You can have a machine generate 10,000 bricks a minute, but if you don't have an architect who knows how to design a stable skyscraper, you just end up with a massive pile of bricks.
Exactly the problem. We have a lot of bricks right now. And then we reach level 3, which the author points out is almost entirely missing in today's tech industry.
Entirely missing.
Pretty much. Level 3 is responsibility for the software lifecycle. This means ensuring that systems remain understandable, maintainable, and sustainable for decades after they are built. What's fascinating here is how completely out of step software is with other major engineering disciplines.
How so?
Well, if you look at civil engineering, Nobody is allowed to occupy a skyscraper without rigorous structural audits.
Yeah.
The finance sector is governed by strict, standardized accounting practices to prevent collapse.
But software which literally runs modern civilization, from our global banking systems to our power grids and hospital records, it operates with almost none of those safety nets.
No.
We measure performance, we measure revenue, we measure how fast our active user base is growing, but the industry rarely, if ever, measures whether a software system can safely survive 10 or 20 years of constant updates. We just keep piling on new features.
Which leads directly to the core danger of the AI era. When code generation becomes as cheap and effortless as breathing, we run the massive risk of producing software the same way factories produce cheap plastic goods.
In enormous, overwhelming quantities.
Yes, without any careful thought given to the underlying algorithms and long-term system structures.
Here's where it gets really interesting. The sources use this brilliant, highly visual, geometric metaphor to explain this architectural crisis. They compare software to baked goods,
Yes.
specifically bagels versus muffins.
I'll admit it sounds a bit absurd at first, but it is one of the most effective and sticky ways I've seen this structural problem described.
It really paints a picture. So imagine a bagel. You have this thick, dense ring of dough. In this metaphor, the dough represents the code itself, the syntax, the files, the sheer volume of instructions that the machine reads.
Okay, but the hole in the middle, that represents the algorithm. The algorithm is the organizing idea behind the system, the core logic that gives the whole thing its shape and purpose. Right. So in bagel software, you have a massive amount of code, but the algorithm is just a hollow, empty space. It's invisible.
Exactly. And because the algorithm is hidden by layer after layer of code, the system becomes incredibly fragile and nearly impossible to safely update.
The sources formalize this concept into what they call the bagel law of software.
Which states what exactly?
It states that when code grows faster than the algorithm that organizes it, the software inevitably becomes a bagel.
That makes a lot of sense.
Yeah, the thicker the dough of code becomes, the harder it is for any human being to see the algorithmic whole that actually gives the system its structure.
I think anyone who has ever tried to update an old smartphone only to have half their apps suddenly crash knows exactly what that digital fragility feels like.
We've all been there.
Now imagine that dynamic, but on the scale of an entire global banking system or an airline. We've actually seen that recently, right? Major airlines grounding thousands of flights because some 30-year-old software system finally buckled under its own weight.
That is the perfect real-world example of bagel software collapsing. The dough got too thick, the hole was lost, and the system broke. And the opposite of that, the ideal we should be striving for, is muffin software.
Right. The muffin principle suggests that sustainable software keeps the algorithm visible right at the center of the system.
Because a muffin is solid all the way through.
Exactly. The center is filled, the structure is coherent, and the internal logic remains understandable to a human being no matter how large this system gets.
Now let's connect this back to the AI boom. According to the author, AI is essentially the ultimate bagel factory.
It's just churning them out.
Right. If you have an AI tool that can spit out thousands of lines of code in seconds, it is generating massive amounts of dough without any guarantee of algorithmic clarity.
It is baking millions of perfectly round software bagels. They might look beautiful and functional on the outside, but structurally they are empty at the center.
And this rapid, unchecked accumulation of bagel software leads to a concept the author calls digital pollution.
Digital pollution. We're all familiar with physical pollution. During the Industrial Revolution, rapid manufacturing growth created unprecedented societal wealth, but it also created smog, toxic waste, and severe environmental damage.
The sources argue that we are currently experiencing the exact same phenomenon, just in the digital realm.
It's a very apt comparison. AI-accelerated code generation is filling our digital infrastructure with opaque algorithms and massive amounts of what the industry calls technical debt.
Let's pause on that term for a second because it gets thrown around a lot.
Sure.
Technical debt is basically the digital interest you pay later for taking shortcuts and writing messy code today, right?
That's a great definition. It's the future cost of having to refactor or fix a system because you chose the fast, easy solution over the well-architected one.
And with AI, we are racking up technical debt at a scale we've never seen before. We are creating systems that nobody truly understands and that cannot be safely modified.
The faster we generate code, the faster this digital pollution accumulates, clogging our infrastructure.
So you're saying we are building massive skyscrapers, filling them with people, and completely losing the blueprints.
Exactly. The real challenge of the coming decades isn't figuring out how to generate code faster, it's figuring out how to achieve software sustainability before we drown in our own digital pollution.
If we connect this to the bigger picture, the strategic documents make a very compelling comparison to Thomas Kuhn's theory of scientific revolutions.
Oh, from the structure of scientific revolution.
He argued that paradigms shift in a specific predictable way. You have a normal practice, which is the accepted everyday way of doing things. Then anomalies start accumulating that the old paradigm simply cannot explain or fix.
And then what happens?
Eventually, this friction leads to a crisis, which forces the adoption of an entirely new paradigm.
The old paradigm here being programming equals writing code. The metrics of success have always been velocity time to market and the number of features shipped.
Right, but the anomalies are becoming impossible to ignore. Exploding technical debt, massive legacy systems that are too terrifying for any developer to touch. And now, AI generating code at a pace humans can't possibly review.
The old paradigm is actively failing, and the sources point out that this isn't the first time the software industry has faced a crisis of this magnitude. Let's look back to 1968.
The NATO Software Engineering Conference.
Exactly. At the time, they were facing what they called the software crisis. Computers were getting rapidly more powerful, but human brains couldn't organize the logic fast enough. Software was constantly breaking, projects were years overdue, and people were genuinely worried that society's ambitions were outpacing its ability to manage complexity.
And the solution to that 1968 crisis was the invention of software engineering.
The professional identity of the programmer shifted.
Yes, you were no longer just a coder hacking away at a terminal. You were an engineer. You had to start thinking about architecture, structured programming, and formalized life cycles.
Then jump forward to 2001 with the Agile Manifesto.
The crisis, then, was a crisis of speed. Development processes which had become highly regimented were too slow and rigid. Companies would spend 3 years building a product only to realize the market had moved on by the time they launched.
So Agile shifted the focus to building software iteratively, collaborating constantly with customers and responding dynamically to change. It revolutionized how software was built.
But the sources argue that while Agile brilliantly solved the problem of speed and adaptability, it didn't solve the problem of long-term survival.
Because Agile doesn't really address what happens to a system over 20 years of constant iteration.
Right. And that brings us to the third historical parallel they draw, which I found totally fascinating, the environmental movement of the 1960s and 70s.
Back then, you had landmark books like Rachel Carson's Silent Spring, which suddenly exposed the devastating impact of unchecked industrial pollution on natural ecosystems.
That realization birthed the entire concept of environmental ethics. Society's focus had to shift toward sustainability metrics, carbon footprints, and conservation. It wasn't just about how fast we could manufacture chemical pesticides anymore. It was about the long-term impact on the planet.
Rakitine is arguing that we need that exact same shift right now, but for the digital world. We're moving from an era of industrial ecology to a desperate need for digital ecology.
And just like in 1968, the professional identity of the programmer has to evolve again.
From software engineer to what?
The central argument is that the programmer must transition from being a software engineer to becoming a digital steward.
Digital steward. I like that.
A digital steward isn't just someone who builds code to meet a quarterly deadline. They're someone who takes moral and ethical responsibility for the long-term life of the digital ecosystems they create.
Their job doesn't end when the code successfully compiles.
That is merely where their responsibility begins.
To really codify this shift, the sources outline what they call the Eco-Programming Manifesto. It's written very much in the spirit of that 2001 Agile Manifesto, but focused entirely on sustainability.
There are a few principles in here that really ground the whole philosophy.
For instance, the core assertion. Software systems are long-living ecosystems. It demands that we stop thinking of programs as temporary throwaway projects and start treating them as critical infrastructure that might outlive the very people who wrote them.
Another principle is algorithmic clarity over code accumulation.
That principle directly addresses the bagel problem. It's declaring that keeping the core algorithm visible and understandable is far more important than just stacking new features and AI-generated code on top of a fragile foundation.
I hear the muffin ideal. I really do. But let's be real for a second. If I'm a startup founder, I don't care about a 20-year lifespan.
Right, you're just trying to survive the year.
Exactly. I'm burning venture capital, and I just want to ship my product tomorrow. How does this philosophy of digital stewardship survive against the pure capitalism of the tech industry?
That is the ultimate friction point, because ethics and manifestos alone do not change massive profit-driven industries.
A startup founder isn't going to slow down just because it's the right thing to do.
To change an industry, you need measurement. You need a way to actually quantify the problem and tie it to financial risk. You can't manage what you can't measure.
And the proposed solution in the text is something called the MSI, the Methodological Sustainability Index.
The MSI, what does it actually do?
The goal of the MSI is to evaluate the long-term methodological health of a system. It measures things like algorithmic transparency, modularity, changeability, and the overall architectural integrity of the code.
It operates essentially as the carbon footprint metric, but for digital pollution.
Exactly. It provides a way to look at a massive piece of enterprise software and objectively say, this is a bagel. It is highly polluted, riddled with technical debt, and poses a severe operational risk.
Or, this is a muffin. It is sustainable and safe to build upon.
Wait, if we're talking about rolling out a new standard, why go through the trouble of creating a complex index? Why not just put this in the computer science curriculum and teach the developers to write better code from day one?
Because the developers aren't the ones setting the deadlines or controlling the budgets.
The strategic rollout plan, detailed in the source documents, recognizes a harsh historical truth about how industrial standards are actually formed. You do not sell a new standard by simply presenting it as a good idea to the people on the factory floor.
You have to make the industry intimately feel the pain of the problem at the executive level.
The strategy document is incredibly pragmatic about this. They point out that financial accounting standards didn't emerge because an accountant had a nice idea. They emerged after massive financial scandals, fraud, and bankruptcies.
Cybersecurity standards didn't exist until corporations suffered catastrophic data breaches that cost them billions. Standards are born from a shared feeling of systemic risk.
Therefore, the strategy for rolling out the MSI isn't to pitch it to everyday programmers. Programmers are focused on the how of building. The strategy is to take this to the people who are terrified of systemic risk.
You pitch it to CTOs, regulators, risk officers, and crucially, the Big Four auditing networks: Deloitte, PwC, EY, and KPMG.
So why should we as everyday users or even regular developers care about corporate auditors like Deloitte or KPMG?
Because just like we rely on health inspectors to make sure the kitchens in our local restaurants are sanitary and safe, these auditors are the only ones who can force tech companies to stop serving us digital garbage.
Exactly. The Big Four handle ESG reporting, environmental, social, and governance, and they audit technology risk for the world's largest companies.
If AI-generated code represents a massive hidden systemic risk to a Fortune 500 company's infrastructure, the Big Four are the ones who desperately need a metric to audit that risk.
The sources also mentioned pitching this to major cloud platforms like AWS, Microsoft, and Google, because they are the ones physically hosting millions of these potentially fragile systems.
And finally, targeting major standards organizations like ISO or the IE to formalize the MSI into a global requirement.
The logic is undeniable. If you can convince the regulators and the auditors that digital pollution is a real, measurable financial and operational risk, then the MSI becomes the de facto standard for software sustainability.
The change doesn't bubble up from the developers, it trickles down from the boardroom to the server room.
It's arguably the only way a paradigm shift of this magnitude actually takes hold. You have to move from explaining the philosophical problem to demonstrating the financial risk of ecosystem collapse and finally introducing the metric as the lifeline.
So what does this all mean? If we step back and look at the whole picture Rakitine has painted for us across these sources, AI is fundamentally shifting the software industry from a world of absolute scarcity to a world of absolute abundance.
We will never ever lack for lines of code again.
But as the manifesto warns, abundance without wisdom is highly dangerous. If we treat software as something that can be produced endlessly and forgotten instantly, we are going to fill our digital world with fragile, polluted systems that no one understands and no one feels responsible for.
The true challenge of the coming decades, the real problem we have to solve, is not generating code. AI has that handled.
The challenge is taking responsibility for the life of the systems we unleash into the world. So to you listening, I want you to keep this in the back of your mind. The next time you are in a meeting or reading a press release and a company is loudly boasting about how fast their new AI can write code, ask yourself a question.
Are they taking responsibility for that code?
Are they baking a muffin? Or are they just running a factory that's pumping out hollow bagels destined to collapse into a mountain of digital pollution?
This raises an important question, and it's one that naturally extends from the deep philosophical core of these sources. The author makes a profound observation that code is just a temporary physical embodiment, a fleeting implementation.
But algorithms.
Algorithms are ideas, and once discovered, they become part of the immortal intellectual infrastructure of civilization.
The hole in the bagel exists even if you eat the dough or swap it out for a different flavor.
Precisely. But here is the corollary we have to consider. If algorithms are the immortal parts of our digital world, it makes you wonder about the legal and ethical ownership of these ideas in an AI-driven future.
If an AI generates a billion lines of code specifically designed to hide an algorithm it scraped from an open-source developer, who actually owns the hole in the bagel?
As AI mass-produces software, the line between original human thought and machine-generated bloat is going to blur in ways our legal system is completely unprepared for.
Wow. If the dough is cheap and infinite, the invisible hole becomes the most valuable asset on Earth. Who owns it when the machine makes it? We will leave you to ponder that one.